Okay, so now we have different concepts related to the forces. Most of them are new for you, just like today we are going to start Hooke's law. Hooke's law is basically related to the springs. So when we try to apply force on a spring, so it will extend, or we can say that the length of the spring will increase, or spring will also can easily be compressed, or rarefaction process is always there. So today's topic is related to the springs, and when we try to hang some load, or when we try to apply some force on the spring, so what are the circumstances and what is the law that actually explains the elasticity of the spring? So the name of new topic is Hooke's law. Okay, so for Hooke's law, basically, if we first write the statement of the Hooke's law, then we try to study the examples of the Hooke's law. So law is very much simple, and the law states that the extension, because the example of spring is also a daily life example, and we all know about the spring, that how spring can be compressed, how spring can be stretched. So the extension of a spring is directly, or we can simply write is proportional to the, right?
Yes.
Okay, so actually, Hooke's law is very much simple, and it is very simply and directly related to the force. And it is a very common example. Let's suppose if we consider a spring, let's suppose this is the original shape of the spring, and we just fix this point of the spring on left, and we try to apply force from right hand side. So all of you know that this spring will stretch towards right hand side, because from left hand side it is completely fixed. So it will be compressed, so stretched like this. So this will be the new shape of the spring, right? Force,
Yes.
and this is the point on left hand side. So according to Hooke's law, the statement is very simple, that if we apply a force, so it is directly proportional to the extension of the spring. It means that if you increase the magnitude of the force, so the length or the extension of the spring will automatically increase with the force, right? But one more important thing is that, let's suppose if we try to pull this spring, or by the external force, or if we apply a great amount of force on this spring, so at some point or at some specific value of force, this spring lose its elasticity, and it will become like a straight conductor or a straight wire, right?
Yes.
Suppose if you apply a greater force on a very soft spring, or we can say that a very low type material spring or low quality spring, so it will become just a straight line. Okay, just a straight wire. You can also take the example of a rubber band. Let's suppose if you try to stretch the rubber band, so after certain value or after some value of force, the rubber band got broke now, because now there is no more elasticity in it, so it completely change its original shape, right? So for Hooke's law, there is one more condition in it. Within the elastic limit of the body, or within the elastic limit of the material, the extension of a spring is proportional to the applied force. So you need to
So I
complete,
have a question.
yes.
How do you know what the elastic limit of like any object is?
Okay.
You make a graph and then you know, like after the force is applied and it doesn't go back to its original shape, that weight from that weight, the limit of proportionality ends.
I will show
Like
you
no formula
experiment.
or anything?
Yes, because always there is experiment. So we try to understand with the help of experiment that how this statement or this explanation or this law actually fits with our example. So the extension of a spring is proportional to the applied force within the elastic limit of a body. So within the elastic limit of a body, right? So now let's try to understand how we can find out the elastic limit. So basically, we try to perform this experiment in laboratory, and in laboratory we need proper apparatus for it. So we can easily measure the weight, we can easily measure the force. So first of all, let me know that which instrument we use to measure the force. Let's suppose if you want to measure a force, so which instrument will
The
help?
Newton balance, or I don't know what you call it.
Okay, and if you want to measure the weight?
Digital scale. Oh, we can use that for the force as well.
Yes.
Spring balance.
Actually, spring balance is for mass,
Yeah.
to measure the mass. If you remember in mass and weight chapter, we studied that there is a comparison between mass and weight. So spring balance used for to measure the mass of an object. And if you want to measure the weight, or if you want to find out the value of weight, so you need to use Newton meter, right? So the
Yes.
same meter helps you to find out the force, right? Because that gives you the value in Newton meter. So it means that that will give you the same calculation for the force or the weight, right? So let's suppose we need to consider different situation for a spring with different weights hang on it. So let's suppose if we are having a base over here and we have iron stands. Let's suppose this is the initial condition, and after some time we will discuss with different weight after different intervals. And one more. Okay, so now let's suppose we use a same spring for the experiment, because our main purpose is not to study the material strength. Our main purpose is to study about the direct relation between force and extension, right? Okay, so if we need to study about the direct relation between force and extension, so let's suppose if we initially consider a spring. So in normal state, this is the original position of the spring, right? Nothing is connected with the spring. Spring is just freely hang with the iron stand. So this is our first stage. After this, let's suppose if we try to hang some equal masses after equal interval. So let's suppose if we hang a mass with it like this. So this mass will be equal to, let's suppose, 20 grams, right? And you all know that how to convert mass into weight. You just need to use the formula W equals to mg. So with the help of that formula, you can easily find out the value of weight, right? And after that, we add the same mass again, 20 plus 20, it will be 40. So a spring will stretch more like this. Okay. So your new value, that will be equal to 50, right? Okay. Now your question is how we know that where will be the elastic limit of the body, right? Or where will be the elastic limit of the spring. So actually, when you are going to perform this experiment, so according to Hooke's law, when you increase the weight on the spring, so extension will automatically increase. Let's suppose if you compare the lengths. Okay, we just consider two stands, remove the third one. So let's suppose if we compare that, what is the meaning of extension, that is also very much important. So you need to draw a reference line. This is our reference line. And in lab experiment, we use a meter rule to find out the distance, right? So this is our initial position, because right now we are not going to perform real experiments. So that's why I used to mark the reference lines to find out the extension. And this is the new length of the spring. And this is the third one, right? So these are three different length at different positions. So if you want to mark the values, so your values will be, let's suppose initially we are having a length of 2 centimeter, then we increase by 4.
Then 4 and then 6.
Yes, it may be any, it is not compulsory that we use 2, 4, 6 every time, because we know that 4
Yeah.
is directly proportional to extension. So if we increase the weight in equal proportion, so your length will also increase in equal proportion, right? So that's why 2, 4, 6, because we add mass 20, 40 like this. Okay. So now if we need to find out the extension, so what is the meaning of extension? Extension mean you need to find out the difference. So the difference between 4 and 2 is equals to 2 centimeter, right? This 4 centimeter shows you the actual length of the spring, right? You can also figure out from the diagram that in diagram number 2, the actual length of the spring is 4 centimeter. But if we talk about the extension, because in the definition they use the word extension. So extension means the difference between the previous length with the difference of the actual length or the new length, right? So you need to compare with the previous length. So every time when you compare the length with the previous one, you always get a value of extension, right? Okay. So actually when you need to find out the extension, you need to subtract the values between initial and final stage. So that will give you the concept of Hooke's law, right? And when we are close to our elastic limit, right? So if we compare from the original, because we have a table of the markings, let's suppose if we draw a table to mark the values in it. So let's suppose in first table we use a mass that we add in our experiment. Then we just simply convert into weight. And the third column will be length and then extension, right? Okay, for initial values, we are having increasing length, right? But after some time, there is a specific length where if you try to add more mass or more weight with the spring, so your length will be constant for some time, right? Your readings, your values of the length will be constant after some time. So actually that specific part or that specific length shows you this is the elastic limit of the spring, right? So actually, during the experiment,
Uh, ex- oh,
so yes. So actually, when you are going to perform the experiment, so according to Hooke's law, your length will automatically increase, your extension will automatically increase with the force, right? But after some time, your length will be stable, or maybe you can say that will be at equilibrium, or your reading will be same after adding some weight, because now we have the concept of elastic limit. So during the experiment, there will be a point will be same particular value of. So initially both values are increasing directly, but after some time your length will be like in equilibrium state for short time. Then if you try to add more weight to it, so that will be exceeding, or we can say that that will exceed the elastic limit of that spring, right? I will also show you the graphical representation because you need to.
Yeah, I was gonna ask for that.
Yes. So you need to draw the graphical representation in the exams also, because it is the important concept in your
what's
syllabus.
the W for at the end?
Yes.
What's the W symbol for at the end? What does it
Wait,
mean?
W. Wait, W. W stands
Like
for
what you wrote.
Wait.
The
Oh.
mass we are adding, so we can simply just multiply with the acceleration due to gravity. You will get the value of W, right?
Oh.
Or you can just simply find out the weight, because we know that the 20 gram will be equal to 200 Newton, right? So you can use the
Yeah.
Newton meter. It's up to you. Our main focus is not to convert the unit. We just simply focus on to find out the direct relation between force and the extension, right? Okay. Now let's try to figure out the graphical representation of the Hooke's law, that how graphical representation, or what is the formula before graphical representation. We need to write out the formula. So the formula for Hooke's law is very much simple. F is equals to, first of all, we need to directly proportional. F is equals to, or sorry, F is directly proportional to X. And when we try to remove the directly proportional sign, so your final formula will be equal to F is equals to minus KX. So this is your actual formula for Hooke's law. F is equals to minus KX. Now there are two questions in the formula. I know you may ask that why
F is equal
negative sign,
minus
K is
K.
the constant.
because we know that K will be constant, right? And I will also explain that what K actually means and why we use minus sign in the formula, right? Because that is a big question, because F
Wait,
equals,
so one more thing. What's that X symbol? Sorry, I was doing
yes,
something.
X is for the extension, right?
Ah, okay, okay.
Because normally we use S or D for the distance, but this is not actual distance or like this. So that's why we use X for the extension. So this is X for extension. And I will explain the concept of K and minus sign over here. So first of all, let's talk about the K. So actually K is your constant value, And what this constant value tells you about, this tells you about the stiffness of the spring. This K value actually explains the stiffness of the spring. To take the example of the shock absorbers in the car, right? The jumps, we can say in simple words, and you compare with the jumps of the motorbike or the bicycle. Let's suppose if we consider the spring that we used in the shock absorber in car and in bicycle, right? So you know that the shock absorbers in car are very much strong and rigid as compared to the bicycle, right? Because the weight of the car is very much high as compared to the weight of the bicycle, right? So actually stiffness means the strength of the spring, right? How much strong that spring is or how much weak that is spring is, the material we are using for that spring. So actually that is the stiffness of the spring, right? The strength of the spring. So actually,
Ah, okay.
yes, K is a constant value that actually depends upon the material that we are using for spring and the strength or the stiffness of the spring, right? Because once we used a silver
So
lead,
like it will be different between plastic and some iron, for example.
yes, but if we are performing a same experiment, so we know that we use the same spring, right? Because we need to find out F directly proportional to X. Our interest is not to find out different material, that is something different experiment. So actually K explains you the stiffness of the spring, and more simple you can say that it depends upon the material we are using for the spring. Okay, material includes all that which metal or how much thickness of the spring we are using for that. Okay, any confusion?
No, sir.
Okay.
No, sir.
Okay, now one more thing, the negative sign. Why we use the negative sign over here? Because there is no concept related to negative sign in whole definition, in whole example. Okay, so the concept for the negative sign is we are using a spring, right? Let's suppose, okay, no issue. I know there will be some connectivity issue in Saudi and different places because of ninth Muharram. So no issue. I will send the recorded lecture also. Don't worry. Okay, so why we are using the negative sign? Actually, if you take the example of a spring, let's suppose a spring is fixed with the rigid ceiling like this, okay? And we connect a block with it, okay? Let's suppose if you pull that block in downward direction and then you release, so what will happen?
The spring will like jump back up.
Yes. So if you try to apply force in downward direction, so this or this spring will stretch, and when you release that block, so it will move in up and down motion like to and fro vibration, or we can say that back and forth motion, right? So your vibration of the spring will be up and down like this. So this is the direction of your motion,
Yeah.
right? Now, what is the concept of negative sign over here? Let's suppose if you try to pull the block in downward direction, okay? So you, we can say that you feel opposite force is acting in the direction that you already applying the force, according to Newton third law, right?
Yeah.
If you try to pull that spring back, so you feel the force, that some force is acting in the opposite direction, in upward direction, right? Because we know that for
Yes.
reaction there will be equal but opposite reaction, right? So the concept of negative sign is very simple. If you try to pull the block backward and when you release the block, so in which direction block will move?
By backward, you mean downwards?
Okay, we make it simple, like if we consider this example on a horizontal surface, so that will be simple for us. So let's suppose if we fix the spring over here and there is a block, and if we try to apply force in forward direction, right?
Yeah, it'll move backwards. Like we'll have like a backward force acting on us.
So your external force is in forward direction, but when you release the block, so block first move in the backward direction.
Yeah.
Anyone? Because
Yeah,
this
that's
is,
correct.
Backwards, right?
yes,
To know.
because whenever you try to pull the spring, so spring will always move in the opposite direction. So that negative sign shows you the concept of that opposite direction, because how much force we are applying on the force doesn't matter, it always move with the same magnitude in opposite direction, right? So negative sign in
Yeah.
simple words shows you the concept of restoring force. Restoring force means because there is a elasticity in the spring, and spring will always try to retain its original position, original state, or original shape. So that's why spring always move in the opposite direction. So this
So does that mean
yes,
does that mean the force would always be negative?
uh, negative sign only for the direction, right? Because force is a vector quantity.
Oh, okay.
Yes,
Okay.
that's why we are using negative sign.
But the value is still like positive.
Yes, board is
Okay, okay.
value will be positive, but negative sign shows you the direction. So that's why.
Direction, okay.
So this negative sign shows you the restoring force, right? And I will write the statement too if someone got confused that what is the meaning of negative sign still now. So spring will always move in the opposite direction, in the opposite direction of light.
Right?
Okay, any
Um, when
yes,
when we make k the main thing of the value, like it will be k is equal to f over x, right? So we do not write negative k is equal to f over x.
yes.
So is it positive k is equal to f over x or negative k is equal to
Negative is just the direction. K is always gonna remain positive.
Actually,
so
negative
when we
sign
shift the
just
formula,
only
then what
for the. Okay, let me tell you. You are getting confused that let's suppose if you are solving the question, right? So are we going to use negative sign or not, right? Let's suppose if the question is only related to the magnitude, so ignore the negative sign, right?
Wait, can you give an example?
Okay.
Okay, for the example, I'm asking that let's suppose in question, if they only ask about the extension, right? Or let's suppose if they only ask about the unknown force, right? Let's suppose the value of k is given in the question and the value of force or the value of extension is unknown, right? Because we have three quantities. Two of them is given in the question and you need to find out the third one. So the use of negative sign is not compulsory in that question, right? Because you need to know about the negative sign, because sometimes they ask in theory question for 1 mark that explain the significance of the negative sign in the formula, right? Or what is the meaning of the k in the formula. So that's why you need to know about both constant terms and the negative sign also. So that is the main theme of this negative sign and the value of k. Okay, any confusion?
No, sir.
So whenever you are going to solve the theory question, just it is just like the difference between speed and velocity. If they ask about the direction, so then you use the concept of velocity. You may use v symbol without direction. It will be okay, right? So when we solve the past papers question, so then I will tell you that where to use the negative sign and where don't you don't need to use the negative sign. So any confusion till now, till the value of k, till the value or till the negative sign?
No, sir.
Okay. The final thing, okay, I just want to mention the definition of elasticity over here, because I hope that you all know about the definition of elasticity, but if somebody has some confusion in it, so let me write the definition first for the elasticity. Because elasticity clears your concept of restoring force, because the example of elasticity in our daily life means the rubber band and the spring, right? So let's suppose if we want to write the definition for elasticity, so we just simply write it is also a property of a body, right? Because it is related to the specific body. So property of a body, or we discuss about inertia, so it is just a copy paste definition of inertia but in different sense. So property of a body which resists the change in the original shape of an object, right? You may also write that property of a body that helps the body to restore its original shape or original position, right? So that is the concept of elasticity. Okay.
All right, sir.